Next up, Adrian Vovk is going to be talking about supporting home directory encryption.
All right, hello everyone, I'm Adrian, and I'm going to be talking about home directory encryption. So the what and the why, this is a talk about systemd homed, which is a service added in systemd version 245 about 4 years ago. And what it does is it manages all your home directories for you. It replaces the traditional etc password and all of those databases with something newer. And it comes with a bunch of benefits. The big one is going to be encryption. So homed will take your home directories and encrypt them on disk. And this is distinct from full disk encryption because each home directory is encrypted with its own key. So this is a more private kind of encryption where your data is only accessible if that specific user is logged in, but all the other users still have their data protected. Homed's encryption is also beneficial because it can actually suspend the encryption at runtime, which means if you take your laptop and close the lid, it will throw out the encryption key and all your data will be protected again until you log back into the laptop. And this is its big selling point. But it has other benefits too. Portability. So usually your user is spread across a bunch of database files all over your system. You have etc password, etc shadow, varlib AccountsService, and this is all over the place. It makes it really difficult to take a user and transition it to a new laptop, for example. Homed does this differently. It puts all your settings in one file called .identity. It's inside of the home directory, which means if you move the home directory onto a different machine, your user now exists on that other machine. Homed is extensible, which means that unlike all the traditional databases, you can actually add new settings to homed over time. It's built to avoid fragmenting itself into a bunch of database files, which is where we are today. And this works because this .identity file is just JSON with a set of standardized keys. So if we want to add more functionality, we can add more keys as it comes up. And fancy authentication. So homed allows you to do smart card logins, and that would be similar to the existing smart card support, except it actually does crypto on the smart card. So the smart card is what is generating the key to decrypt all your data. So it's a more secure form of smart card authentication. And this will also open the door for kind of Windows Hello-esque features like cryptographically secure fingerprint readers. And maybe you know, secure enclave TPM things we can put together to emulate something as secure as Windows Hello or Mac OS's authentication. And that was a really quick summary of homed. If you want to know more about homed itself, there's a talk at All Systems Go 2019 where Leonard discussed it. Just keep in mind this talk is from 5 years ago. So Leonard will mention some limitations that are not a thing anymore. They've been solved since then. Most importantly is SSH login. We've fixed that. You can log into SSH with a homed user now. Yeah. All right, so if homed is so great, why aren't you using it yet? Well, there's a couple components missing. For one, your lock screen. So homed works it will re-encrypt your home directory when you put your computer to sleep, and the normal GNOME lock screen is running within your session and it needs access to the home directory. So the issue is if we keep things as they are, when you open your laptop again, the lock screen might be completely non-functioning and you will not be able to log back into your system, which is not good. And the second thing that's missing is AccountsService. And AccountsService is GNOME's source of truth about what users exist on the system, what their name is, what their profile picture is, and so on. And it's also used by GNOME to change users. AccountsService will actually look at etc password directly on disk. It doesn't use any APIs that homed hooks into. And so AccountsService just has no idea that HomeD users exist in the first place, and therefore GNOME has no idea that HomeD users exist. All right, before I get into talking about all the work I've done, there's some language that's confusing about HomeD. There's a lot of terms that have multiple meanings, and they're all used together at the same time. So, for example, the lock screen, what is that? With HomeD, there are now 2 lock screens. So the first one is the screen shield, and that's the existing traditional one where it's just UI that's placed over top of your session. And until you type your password in or re-authenticate some other way. And now there's this new secure lock screen, as I'm going to call it, and that is the secondary lock screen that is now running in GDM outside of your session, which will allow HomeD to function. Encryption key, there's a couple of these involved. It's usually going to mean the volume key, which is the actual key used to actually encrypt the data on disk. But I'm going to put 3 dots there because there's other keys and there will be more keys in the future. So just keep in mind it's a loaded term. Suspend, there's a couple different definitions of suspending too. There's your normal system suspend that would just sleep. Just you close your laptop lid and it goes to sleep. And then there's something called Lux suspend, and this is really the core of HomeD's functionality. Basically what it does is it erases your encryption key from memory to prevent data from being decryptable. And then it will freeze all incoming I/O requests. It'll actually just leave them in a queue forever until you log back in and Lux resume. And this will freeze that thread. So if you have a process in your user session that's accessing the disk, it has a risk of being frozen, but other processes will happily keep running, and this will be a problem, as we'll get to later. Lock, this has, again, multiple definitions. We have the traditional lock, which is the existing lock screen, where a screen shield is just placed over a running session. Then we have a HomeD lock. This is a really low-level concept in HomeD, actually, and it is basically a Lux suspend with some state tracking added on top of it inside of the HomeD service. So a HomeD lock isn't actually what we want, and systemd unfortunately exposes some UI for it. So you could type home control lock. You don't ever want to do that. That's a HomeD lock, and it will break your session. So what you actually want is a secure lock, and this is what the designers decided to call it, at least for now. So this is a user-visible name for it. And this is a HomeD lock with additional plumbing placed on top of it. So it'll be, it'll tell GDM to put itself on screen. It will actually warn apps about the fact that they're about to get encrypted. So apps have time to prepare, maybe close file descriptors, flush some of their own caches. Like something like Signal, for example, might have its own encryption keys in its own memory that it might want to get rid of when you're going into a secure lock. So apps can respond to this via APIs I'll talk about later. All right, so now that that's out of the way, let's talk about all the work that's been done. Freezing. As I mentioned before, a Lux suspend will put your session in a weird state where half of it can be frozen and half of it can be running. This is bad because GNOME shell might get frozen and your dbus daemon might not. Dbus daemon decides that GNOME shell has crashed and will disconnect it from the bus, which means the next time you log into your system, your session is gone. And this has been fixed, and it's released in systemd version 256. Blob directories. I mentioned earlier that these .identity files that define HomeD users, they're JSON, and JSON cannot store binary data. Which means something like your profile picture, which is an important part of your user identity on your system, is impossible to store with HomeD. So that needed to be corrected, and this was actually a little more involved than you'd expect because HomeD has a lot of requirements about the integrity of this user record file. It'll actually sign it and verify that signature. So we needed to support that with these blob directories. But we support that now. The API is quite convenient. You basically get a directory and you have well-known file names in there to put things like your profile picture. And that's also been released in version 256. Updating records. As I mentioned, HomeD is pretty strict about record integrity, and it was actually a little more strict before I got to it. It wouldn't let you edit a record unless you typed in the user's password. Any edit you want to make, you had to re-authenticate, and this isn't convenient at all because system administrators should be able to, for example, impose limits like RAM usage limits on users without having to know their password. So the first step to fixing this is we made it so that HomeD can actually listen to administrator overrides on settings. So if the user's logged in, the settings are applied immediately, or we reuse the key that's already in memory to propagate all the settings into the home directory. If the user's not currently logged in, we will put those changes to the side, we'll save it in var, and then the next time the user logs in, all those settings get applied. So yeah, that solves the problem. So administrators can now change user settings without user involvement. So that part has landed in 256 also. The second part to this is letting users change some of their own settings. And this can actually be quite dangerous because group membership is in this same file. So if a user can add themselves to the wheel group, for example, they become an administrator, and we don't want that. So we have an allow list that we've added, which will basically limit what a user can change about themselves, and it's limited by default to things like your username, sorry, your real display name, your profile picture, things like that. And this is still work in progress, but it will be convenient to have this landed once things like GNOME settings will start talking to HomeD directly. For now, it's not strictly necessary for HomeD. All right, and finally, and this is the biggest piece, is this login plumbing. I mentioned earlier the distinction between a HomeD lock and a secure lock, and all of the secure lock machinery has gone into login. We've added new APIs to login. Some of these APIs we might want to push through GNOME session eventually, so that apps have a user space safe API they can talk to. But the plumbing is there in systemd to do that. It's all in login. This is still pending. This this is what I was working on when I was reassigned to a different task. Yep. An account service. This is the account service work is basically about making account service look up HomeD users, enumerate them, and allow changing them too. It's all there. We did everything we could fit into the existing account service API. Most notably, we couldn't fit password changes. So account service cannot change a HomeD account's password because account service's API is just not compatible with that. So clients will need to talk to HomeD directly to achieve that. And account services HomeD support has recently, like about a week ago, landed into their Git main branch, so it will be in the next release. All right, those are all the upstream changes, and now here's everything that needs to happen in GNOME. And all of this is work in progress. None of this has landed yet. Some of it's been kind of reviewed, but initial reviews, things like that. So settings, as I mentioned, account service cannot change passwords. So settings can now talk to HomeD directly to do that. Same with initial setup. Initial setup has to talk to HomeD directly to create a user and then set their password because we cannot do that through account service. The secure lock screen, that needs support. So GDM connects to all of this login plumbing that we've put together to start a special session that's running on a separate virtual terminal. And then GNOME shell has special UI added, a new session mode, that allows it to show the normal screen shield with nothing underneath it, and all the bug fixes that go with that, because the screen shield wasn't designed for that initially. And then GNOME OS. This was kind of the obvious testing platform for all these changes. So there's a patch set to apply everything on top of GNOME OS, and we can build a GNOME OS image with full HomeD support. And if you want to get the latest updates about what patches are necessary, what versions of everything you need to be running, check that merge request for GNOME OS. If you're a distro and you're looking into possibly supporting HomeD, this is what you need to implement to support HomeD in your distro. All right, future work. Because this work isn't done, we need to land everything that is still pending, reviews, at rebases, all of that. I would suggest that we start phasing out AccountsService, and by that I mean clients should start talking to HomeD directly. My understanding is that AccountsService was a temporary solution that became permanent, and so we have unified APIs in systemd now to kind of replace AccountsService. So if you want more details, come talk to me. Fancier auto secure lock. Right now, if you close your laptop lid, it will re-encrypt. So whenever your system is suspended, it will re-encrypt your data, which is great for a laptop. It's terrible for a phone, because when you're locked, you don't get notifications, you don't get music playback. All of that is frozen and not running. So we need a fancier UX to decide when to lock, when not to lock. Should we lock after 24 hours of inactivity, something like that. Auto resizing. Due to limitations of the kernel, well, first of all, HomeD uses loopback files for the home directory, which means they have a fixed size, and due to limitations of the kernel, we cannot elegantly resize them dynamically to emulate this, like you have one/home directory and then all the users share that space. We need changes in the kernel for that. Come talk to me if you're interested in working on that. I can point you in the right direction. Cache purging. Right now, the kernel will keep decrypted file contents in cache, in the page cache, and it's even if you use like a USB stick, an encrypted USB stick, this is the case. There's mitigations in the kernel that will let this cache be wiped eventually, but they tank system performance. So this requires more kernel work. Again, come talk to me. I can indicate our ideas on how to fix that. And finally, this is the big one, encryption layering. Right now, if you want to put multiple encrypted partitions on top of each other, you get exponentially worse performance because you're encrypting the data over and over and over again. I took some inspiration from Android and put together a proposal on how to layer encryption on top of itself at the cost of encrypting the data just once, which will allow very fancy use cases like having HomeD protecting your entire user, but then individual Flatpak apps get their own data encrypted again with per app keys. So that way, your banking app, for example, can lock itself even during a normal insecure lock. This, again, requires kernel work, and come talk to me. There's no time for a demo, unfortunately, but I have a laptop running this weird GNOME OS build, so I can come, if you come talk to me, I'll demonstrate it for you. And I want to thank the Sovereign Tech Fund for funding all my work. I want to thank the GNOME Foundation for administrating the fund. I want to thank Sonny Piers and Tobias Bernard for organizing that grant. I want to thank Leonard for designing and developing HomeD and then helping me with reviews and coming up with solutions to all the problems. And I want to thank Ray Strode, Marco, Valentin, Felipe, and all the other reviewers that have been helping me land all of this so far. Yeah, I'm happy to take questions.
Maybe I missed this earlier, but is your directory created encrypted at user account creation time, or is this something that can be done post-install, and can you add and remove encryption to an existing home directory like that?
On the home directories, you mean?
Yeah.
So there's a specific, there's a loopback file with a very specific partition table structure inside of there. There is a somewhat unofficial tutorial about how to take your existing user account and turn it into an encrypted HOMD user. But if you want the encryption, generally the recommendation is to just create a new user and then copy all your data over. You know, do something like that.
Okay, so there's no migration step that would have to be done.
Yeah.
Is this on? Oh, okay. Sorry. In terms of phasing out AccountsService, I mean, it's true that it was designed to be temporary and obsoleted by something that never came. And it's not the greatest library and service that we have in our desktop. But if its replacement is systemd HOMD, well, I know some distros like Fedora are very interested in systemd HOMD, but others will probably just revert whatever changes we do and patch AccountsService back in. So I'm curious thoughts on that, and also the password changing APIs. I wonder if it might be possible to just add a new API for password changing to AccountsService and tell people to use that instead of the older one. The AccountsService library APIs, in particular, they're worse than the dbus APIs. So I think the dbus service isn't too bad.
So systemd actually has an API below HOMD. It's called UserDB. And it's designed to be super extensible. We could put LDAP in there. We could put normal user accounts. And it's pretty trivial to implement. So I think people that don't like systemd can kind of split that out into their like kind of UserDB D or whatever they want to call it. So I don't think that's necessarily a huge concern. As for adding APIs to AccountsService, the problem is that AccountsService combines reading user settings with changing them in ways that aren't compatible with all backends. So if you have like an LDAP user, for example, maybe you can't change a password. Maybe you can, maybe you can't. So clients kind of need to be aware of what kind of user they're dealing with anyway, and at that point, why not talk to the native API of that user if they already need to support them case by case anyway. It's kind of my reasoning for it. But we can discuss that more later.
So I know there's more questions, but we're out of time. Please, approach Adrian in the hallway or ask them in the channel. So next up, for the next 5 minutes, we have a break. And in this room, we'll have making WebKit GTK accessible again. And track 2, we have AI navigating the chaos. Those will start at 1:55.